Hey guys, I wanted to put together a quick, just really a quick video that compares accuracy and precision in chemistry or in any science. These words tend to be used interchangeably in our everyday language, but they kind of mean different things when we're dealing with sciences. Okay? These are two definitions that really, if you can just keep this in mind, you're going to be just fine. Accuracy is being close to the true value. So if you were given data, you would find the average to compare it to and compare it to the true value. The closer you are to the true value, the more accurate you are. That was my dog. As opposed to precision, which means the exactness of one measurement or the repeatability or closeness of data, the closeness of data points in the data set. In that case, you would find the range. Okay, so looking at these dartboards here, I would say the top left dartboard is not precise. The darts are scattered a little bit, and they're not close to the target, to the center of the target. So that means that set of dart shots is not accurate. So not precise because they're spread out, not accurate because they're not close to the true value. Okay, what about the top right side? All right, this might sound a little bit weird, but they're not precise because they are scattered. That's probably not surprising. But I would say that this is accurate because, if you were to average out these different shots, you would get something that's pretty close to the true value or the middle of the target. Okay. In the lower left-hand side, we've got a bunch of dart shots that were very close together, so that's precise, but not accurate because they're off of the center of the target. And in the last one, all the dart shots were very close together. They were right on target, right in the middle. So we are precise and accurate. So we're going to go on and use these definitions now to go to the next page and look at some data in a data table. Okay, so here's some data, and really pay close attention here. You will probably be asked to do this on an assessment, okay? Hint, hint, okay? So let's remember what precision means. Precision means how close data points are together. So we would be looking at a range within the data, okay? Accuracy is going to be how close is the average of these data points to the actual value. Okay, so first I'm going to take a look at the range here of these data points, and we'll see what we come up with. All right, so I just calculated the ranges here. All right, so I took the ranges, I found the ranges by taking the smallest number in each data set. So for student A, the smallest number was 13.87, and then subtracting that from the largest number, which was 13.40. Subtracting, I get 0.51 cubic centimeters. That's the range for student A. The range for student B, taking the largest number from the smallest number, I got a range of 1.11 cubic centimeters. And then for student C, taking the largest number minus the smallest number and finding the range, which was 0.12 cubic centimeters. I'm looking at these ranges. I'm finding that the range for student C is the smallest range. So student C's data is the most precise. Okay, so who had the most precise data? Student C. Who had the least precise data? Student B. Okay, so I took the average values for student A, and I got an average of 13.73. I took the values for student B, found the average, got 13.46. Took the data for student C and found the average to be 13.63. Okay, now looking back at the problem, the actual density of mercury is 13.47. So I'm going to make a little note. 13.47 is the actual average. Sorry, I meant to say the actual density is 13.47 grams per cubic centimeter. So now what we want to do is see which of these averages are closest to the actual, okay? So I'm going to work that out. All right, so what I did is I found the difference between the averages and the actual. For student A, the difference was 0.26. For student B, the difference was 0.01. For C, the difference was 0.16. So when it comes to accuracy, student B is more accurate, the most accurate. And the least accurate is student A with 0.26. So that's about it. We found how to find precision in a set of data. We look for the range. We found out how to find the accuracy of a set of data. We take the average of that data and compare it to the actual. Okay? All right, one last thing. We're going to look at the percent error in this data now. Okay, this is one last thing that we need to talk about. It's rather simple, but just stick with me. All right, now this is in the guided notes for this class. Calculating percent error. This is the formula. You take the experimental value, like for instance, these values. These were the experimental values that these students came up with. And then you take the actual value, which we know in this set of data for the density of mercury. The actual density of mercury is 13.47 grams per cubic centimeter. Take the experimental value, the one that these students got, minus the actual value, divide that subtraction from the actual value times 100. Okay? I'm going to now calculate the percent error for each of these students. All right, I've done all of these calculations. I took the experimental value minus the actual value divided by the actual value times 100. And I found the smallest percent error, of course, was student B. You might also notice that I stuck with the correct number of significant figures. Maybe I didn't have to do that. I would say this, guys. If you're wondering, do I really need to worry about significant figures? I would say, when in doubt, just do it. You know what I mean? It doesn't hurt. It doesn't take that much extra effort. I put my answers here in the correct number of significant figures. All right, I hope that's been helpful, and thank you, and I'll see you in class.